The next topic that I want to talk about involves integrals with trig functions in them. In particular, right now, we're going to look at integrals of type integral of a power of sine x times a power of cosine x. If you have one of those powers as an odd positive whole number, or if both powers are even, then there are things that we can do with this. After that, we're going to look at integrals that have sine of a constant times x times cosine of a constant times x with respect to x, and variations on that theme. The first type of integral that we'll look at is the integral of a power of sine of x times a power of cosine x dx. The trig identities that we're going to use for this involve cosine squared plus sine squared equals 1, which obviously can be rewritten as sine squared equals 1 minus cosine squared, or also cosine squared equals 1 minus sine squared. Our first recipe is going to be this. If one of the two powers on the sine or cosine is an odd positive whole number, then we're going to split one factor of that function off and convert the rest of the stuff in the integral into the other function using our trig identities. It'll be easiest if we look at an example. The easiest example of this sort of thing is something like this. We want to find the integral of cosine cubed x sine squared x dx. The thing that should draw our attention is the 3. 3 is an odd positive whole number, so I'm going to take one of the 3 factors of cosine x and split it off, write it down beside the dx. That leaves 2 factors of cosine x behind and the sine squared that we had. Because of our trig identities, though, cosine squared is 1 minus sine squared. And then, if you look at what you've now got, there's a function, sine x, and its derivative, cosine x, also shows up. We'll make a substitution. Letting u equal sine of x, du dx is cosine x, du is cosine x dx, cosine x dx, that is to say du, is that. The rest of it, 1 minus sine squared, is 1 minus u squared, multiply by sine squared, multiply by u squared. Cosine x dx is du. I'm going to integrate u squared minus u to the 4th power with respect to u. This is a polynomial. It's easy to integrate. And then you remember that u is equal to sine of x, and then you have obtained your antiderivative. As another example of this, let's look at the integral of square root cosine x multiplied by sine cubed x dx. Even though at first glance this doesn't seem to be of the type that we're talking about, when you remember that the square root function is the same as the raised to the 1/2 power function, you see that it is. The odd positive power is the 3 on sine cubed of x, so split one of those factors away. The remaining sine squared can be written as 1 minus cosine squared, and then just as before, we can do a substitution. We'll let u equal cosine x, meaning du dx is negative sine x. du is negative 1 times sine x dx, which of course means that sine of x dx is negative 1 times du. If you write all the pieces in, group the two middle factors together using the associative law, write the negative of 1 minus u squared as u squared minus 1, we get something that's not a polynomial, but is almost as easy to do as a polynomial. U squared is u to the 4 halves. U to the 1 half times u to the 4 halves is u to the 5 halves, minus 1 times u to the 1 half power. These are now things that are easy to integrate using the 1 over n plus 1 u to the n plus 1 power rule. And then, remembering that u is an abbreviation for cosine x, we obtain the antiderivative. If both of the powers on sine and cosine are positive even whole numbers, then the preceding facts won't help us any, and it turns out that we have to make use of two other trig identities. Cosine squared of something is 1/2 times 1 plus cosine of 2 times the something. Sine squared of something is 1/2 times 1 minus cosine of 2 times the something. As an example of this integration technique, let's look at the integral of cosine squared x times sine squared x. I don't have any odd positive whole number powers, so that's not going to help me. But on the other hand, I can express cosine squared of x and sine squared of x in terms of trig formulas that don't have any squares in them by using these two identities. Writing in what we know cosine squared x and sine squared of x to be, we get the integral of half of 1 plus cosine 2x multiplied by 1/2, 1 minus cosine 2x. We've got two factors of 1/2. We can pull those out in front of the integral and write it as 1/2 times 1/2, or 1/4. The quantity inside the integral is 1 plus something multiplied by 1 minus something. Using well-known facts from algebra, that product is 1 squared minus the something squared. 1 squared, of course, is just 1. We have gone from having an integral that had two squared trig functions in it to an integral that has only one squared trig function in it. If we do our identity again, we should be able to reduce this down into something that only has the first power of a trig function, and then we ought to be able to deal with that. Inside the integral sign, the thing that I'm subtracting away from 1 is cosine squared of something. We know that to be 1/2 multiplied by 1 plus cosine of 2 times the something. 2 times 2x is 4x. 1 minus 1/2 is 1/2. Then I'll have minus 1/2 cosine of 4x. I can factor another 1/2 of that, 1/8 integral 1 minus cosine 4x, and then finally, we know how to integrate that. This is 1/8 multiplied by the quantity x minus 1/4 sine of 4x plus a constant. If you go back and look at the review of trigonometry that we did, we derived several formulas. One of them was cosine u times cosine v is 1/2 cosine u minus v plus cosine u plus v. The sine of v, is 1/2 cosine u minus v minus cosine u plus v. And sine u cosine v is 1/2 times the sine of u plus v plus the sine of u minus v. Since sine times cosine is the same as cosine times sine, we don't need another formula. 3 will do. As an example of the usage of this, if you want to calculate the integral of cosine 5x times cosine 3x with respect to x, I will use the formula that tells me about the product of cosines. I'll use this one. I'll think of the u as being 5 times x and the v as being the 3 times x. The thing that I'm integrating is the same thing as 1/2 times the sum of two cosines. The first is the cosine of u minus v, the cosine of 5x minus 3x, the cosine of 2x. The other, cosine u plus v, is going to be cosine of 5x plus 3x, that is to say cosine of 8x. So I have to integrate 1/2 times the quantity cosine 2x plus cosine 8x. Obviously, I can take the factor of 1/2 out front, and what remains is easy to integrate. These are the variations on a theme on integrals based on cosines and sines. This is the first of 2 parts that we'll look at. In the second part, we'll look at similar integrals that involve not cosine and sine, but tangent and secant instead. I hope everyone's having a good day. I'll talk to you again soon.